Welcome back everyone to my channel. In this video, we are going to learn about an essential programming skill which is error handling and exceptions in Python. So let's get started. Errors are the mistakes committed while writing the program code. Normally we encounter three main types of errors. These are syntax errors, logical errors, and runtime errors. The first type of errors are syntax errors, which are the mistakes made while writing the program code. Think of it like grammatical mistakes in a human language. An appropriate error message is displayed when the parser detects an incorrect statement in your code. One of the most common syntax error that we encounter in our programs is missing colon. So in this case, I was writing a function and I forgot to put the colon mark. So Python interpreter has indicated that there is a syntax error and it was expecting a colon mark right after the function name. Another example of syntax error is that if I am writing here 5 plus 4 equal to C. So the Python interpreter is indicating that there is a syntax error as it cannot assign to expression here. C should be on the left hand side and the expression should be on the right hand side, and therefore it leads to a syntax error. The second type of errors are logical errors. These are also known as semantic errors and these occur when there is an error in the logic or algorithm of the program. In case of a logical error, the program code runs but produces incorrect output. Suppose that in this case I want to generate the output for this expression. So when I print it, I get 11.0 as the output. Whereas my actual expression was this. I want to put parenthesis around 4 plus 5, then in that case the output would be something else. So whenever there is some kind of error in the logic of the program leading to some incorrect output, we say it is a logical error. And the responsibility here lies with the programmer to identify and correct these kind of errors. The last type of errors are runtime errors or exceptions. These occur while the program is running and disrupt the normal flow of execution of the program. Let us see a few common exceptions in our programs. Suppose I try to print here the name of a variable and I haven't assigned any value to it. In this case, I got an exception called name error which says that name my variable is not defined in the program. In another example, let us suppose that I am adding a string to a number, let's say an integer, say 19. In this case, I get another type of exception called type error which says that we can only concatenate a string to a string, not a string to an integer. Now let us suppose that I have a list of numbers, say 1, 2 and 3, and I am trying to print a value inside the list at index 3. Now in this case, it is very clear that this value 1 is stored at index 0 by default, 2 is at index 1 and 3 is at index 2. So there is no index 3 in my list. But if I try to access index 3, then it leads to index error. That means list index is out of range. So everyone, such type of errors which occur during the execution of the program are known as runtime errors or exceptions. So why to handle errors? First of all, efficient error handling is required to ensure that your program runs smoothly without crashing during unexpected situations. Secondly, it improves user experience by providing meaningful error messages that help the users understand the underlying problem and reduces their frustration and confusion. Now let's get into how to handle these exceptions. The basic exception handling mechanism in Python is pretty straightforward. One or more statements that might contain an error are included inside the try block. If an exception occurs during the execution of the program, then the except block will be executed. In case no error occurs and the program runs error-free, then the else block will be executed. And regardless of whether an exception occurs or not, the statements inside the finally block will always be executed. Let's see an example. Suppose that in this program I want to check whether divide by 0 error occurs or not, then in that case I am going to use try except block. So first of all, I'll type the keyword try and put a colon mark. In the next statement, I am going to declare one variable called number and I will prompt the user to enter an integer value. Now we already know that the input function always returns a string. So we need to convert that string into an integer value using the int function. So here type conversion is being performed from string to integer type. And in the next line, I am going to get my result in a variable called result. Let's suppose that I am dividing value 10 with the number entered by the user. In the next statement, I am typing here except, and here I will check if the number entered by the user is 0, then it will result in zero division error. So here I will type one statement which says you cannot divide by 0, and this is the message that will be displayed in case user enters 0. The try except block is now complete, and here I am going to put a value. Let's say I put 0 only. So the Python interpreter displays the message you cannot divide by 0. Once again I am going to run this statement, and let us suppose this time I enter value 5 and nothing happens. There is no output, but there is no error also. That's because I haven't displayed my output anywhere. I just calculated the value, but I am not displaying it anywhere. So now I can display it using the else part. So once again I am going to run the same code, and here after the except part I'll type here keyword else, and then in the next line I will print my result using an f string. So f string works like this. We type here f, then put double quotation marks, and here whatever statement you want to display. So I want to display the result is equal to, and then inside the curly braces mention the variable whose value you want to replace. So I want to replace the value of variable result, which is this same variable, with the value that is calculated in case the value entered by the user is not 0. Okay, close the bracket, press the enter key, and now if I enter here, let's say 5 once again, then the result is equal to 2.0. We can also throw multiple exceptions in Python. Let's do it. Once again, I am going to type the same code. I will type except. Now notice that for zero division error, I specifically mention the error name which says zero division error, and then here in the next line I am printing you cannot divide by 0. In the next line I am throwing another exception which says value error. Let us suppose that the value that the user enters is not an integer value, then in that case value error will occur, and here I am typing invalid input, then type please enter an integer only. In the next line else part will be written, and once again using f string I am going to print the output. The output is equal to, and here I will type the variable name which says result, close the bracket, and then we have finally. Here you can type anything or take any action. So here I am saying code executed successfully, press enter key. Suppose that here I enter ABC instead of an integer, and here you can see that there is a value error, and this message invalid input please enter an integer only is displayed, and then the code inside the finally block is executed. Let's rerun the code, and this time I am once again dividing the value with 0. So here we have you cannot divide by 0 and code executed successfully. If you run this perfectly, let's say with some value, let's say I enter here 4, then the output is 2.5 and code is executed successfully. So I hope it is clear to you that we can throw multiple exceptions. You can also throw multiple exceptions in the same line. So let us suppose that for any kind of exception I want to display a single message, then I will have to put all the exceptions in the same line separated by a comma inside parenthesis, just like this. And here I am typing except zero division error comma value error as E. E stands for exception. I am going to erase this line, also this line, and here this line will be something else. So let's say I am typing here some error occurred, and this is the message. So irrespective of what kind of exception took place, the same code will be generated for all. Let's say I enter 0, so some error occurred, and now once again if I run it, let's say this time I enter a string value. So here I entered some string, and you can see some error occurred messages again displaying. So this is how you can work with multiple exceptions also. You can also raise your own exceptions using the keyword raise when a certain condition occurs. Let's see an example. In this case, I am going to create a function called checkPositive which will accept a parameter called number, and here I am checking if the number value is less than 0, then I will raise a value error. This value error will define my custom error which says number must be positive, and in the next line I will type return number. So this number will be returned only if the value is bigger than 0. If it is less than 0, then this value error exception will be raised. So my function is now complete. Let's call this function. So here I am typing checkPositive with value 0 and it returns 0. Let's call this function for some value which is bigger than 0, let's say for 100. Then it returns 100. Let's call this for a negative number. Let's say I enter here -1, and in this case there is an error, and here you will notice value error, number must be positive. So the same message which I entered is displayed over here. So this is how you raise your own exceptions. Let's talk about the assert statement. Assert is a keyword that is used while debugging the code. Debugging is the process of identifying and removing errors or bugs from the program. The assert keyword lets you test if a condition in your code returns true. If it is not true, then the program will raise an assertion error. Let's understand this through an example. Let us suppose that I am defining a function called divide which accepts two parameters, say a, b. Inside the function, I am going to use assert keyword to make sure that the value entered for b by the user should not be equal to 0. In case it is equal to 0, then we will display one message which is an assertion error which says that the denominator should not be 0, and in the next line I will return a divided by b. Let's call this function now. So function name is divide. Let's suppose I enter here 8, 2. In this case the result is 4.0. Let's call this function again, but this time I am replacing denominator 2 with value 0. So we got assertion error here in the last line which says denominator should not be 0. In this way you can use the assert keyword to check any condition during the development process to make sure that your program is error free. Now let me throw some light on the difference between try except, raise and assert statements. First of all, try except is used for handling errors gracefully whenever they occur in the program. Raise, on the other hand, allows you to signal that an error has occurred or to throw your own custom exceptions. While assert statement allows you to catch errors during the development process that should not occur if your code is correct. So guys, in this video we have learnt about errors and their types, basic error handling mechanism in Python, raising exceptions and the assert statement. I am wrapping up this video with a few practice problems. Please try them on your own. If you have any comments and suggestions, then please mention in the comment section below and also give this video a thumbs up. And I'll see you in my next video where I will be discussing about file handling in Python. For more videos like this, please share and subscribe my channel Programming Horizons.